This is my unit 2D corrections for physics. Okay, this is my first question for correction. It's on the multiple choice. It is the third question. It is asking us to find the change in height of an object that is launched at 40 meters per second at an angle of 30 degrees and it lands at 3 seconds. So I got it. The correct answer is 15 meters above the ground when it lands on the plateau. For every single question, the notes will be at the end of the clip. Okay, so basically, we use the fourth equation and then we plug in those values. So you do change in y equals 40 sine of 30 times 3 plus 1/2 negative 10 times 3 squared, which would give you 20 times 3 plus negative 45, which would equal 60 minus 45, 15. So the reason, so this is the answer. The reason I got it wrong was because instead of 60 and 45, I got a different number and I put 30 meters. So that's why I got it wrong. Okay, now next one is question 6. This question was asking an object falls or is launched off a cliff at a certain angle and velocity, and the choices were to see which angle would cause the object to travel the farthest horizontal distance. So the notes will be at the end of this video. So at 45 degrees, the maximum distance it traveled, the maximum horizontal distance it traveled is at 45 degrees. However, since this is in an elevated plateau, any angle higher than 45 will not go. It'll go maybe like this, right there. But if it goes less than 45 degrees, it has all of this space to fall down. And with the increased speed in the x direction and the increased time it takes to go down since it's elevated, it'll travel a much farther distance than if you just shot it up at 60 degrees. That's why the correct answer choice here is C, which is greater than 0 but less than 45 degrees above the horizontal. I think the reason why we got it wrong was because we changed our answer because our reasoning was off or bad. This is question 11 on the multiple choice for the 2D corrections. An object has been launched and is falling down. This is position and this is time. And it's asking us to find the relation of position with regards to time. So this is a parabolic pathway, but how do you prove that? You use equation 4. Change in y equals v0 times t plus 1/2 gt squared. And the degree here is 2, that makes it a quadratic equation. So that means position, change in y, is related or is proportional or directly related to t squared because it's a quadratic. And you can see with the curve. If it was inverse, it would be like this. If it was any other thing, if it was linear, it would be like this. If it was cubic, it wouldn't even be possible. The reason why we got this wrong was because we thought that with this equation, if you were just to plug in values, it would be a constant number. We didn't think of the actual equation's behavior itself. We just thought since each number has a single y value, it has to be directly related, which is, it is true, but how is it directly related? We didn't answer that part. This is FRQ 1, question 16. So we only got 1 out of 2 points. 1 point was given for identifying quantities that would allow students to determine data. Another point was earned for correct equipment to measure the identified quantities. We got the first or the second point because we measured the x distance in meters, but we did not, and we also measured velocity, but we did not measure or use these instruments to measure data. That's why we got it wrong. So I guess you could say that we didn't follow instructions and we did not read the question correctly. That's why we got it wrong. Okay, now this is the same FRQ. This is question 16 on the 2D test. We got 1 out of 3 points on this portion. The points were distributed as follows. 1 point is earned for a procedure that is consistent with the equipment and quantities from part A. For reducing error by doing multiple trials of varying quantity, that's another point. And 2 points for manipulating a single quantity. And we got 1 point for multiple trials. However, I would argue that we use the equipment from the question before part A. We use the meter stick to measure how far each ball flew. And we measured the velocity, which was given to us, that we thought it was given to us. No, we manipulated two quantities. So I would argue that we got 2 out of 3 points, or two out of 4 points on this one. The notes will be at the end of this clip. Same thing as before, we didn't read the question and we didn't understand it fully. The next part is part C in FRQ 16. We got 0 points on it out of 1. So we got it wrong. Okay, so we got the equation that the inverse of tan equals 2 v naught squared divided by g times x. So what we graphed is 2 v naught squared over g of x, which is rise over run, which is not right because v naught of x was not given to us. In the y, it should be v naught squared. In the x, it should be the x distance traveled, or d. I would say our equation was wrong. That's why we got this. Or we could have just used the constants or the changing variables, because this wouldn't really matter. Yeah, I would say that will be our mistake for this section. Okay, this is part D on FRQ 16. This is asking for, what it says, describe which information from the graph described in part C will be used and how would it be used to determine the angle. So, according to the answer key, the equation we should have got was the change of x equals v initial square, or v naught square, whatever, over sine of 2 theta over g. So if you multiply it out, v naught will go over here, rise, g will go over here. No. Yeah, no. V naught would be the rise. This would be the slope. This would be the run. Yeah. Okay, so let's see. The slope should have been sine of 2 theta over g, because this is m, this is x, and that is it. We got our slope. Our slope should have been 2 over g. That would have been wrong though, because it's not close to this. Well, you could just remove all of that. But 2 over g, but we didn't put that. So either way, it would have been wrong. It was all because our equation was not correct. Okay, now this is on to the next FRQ. This is question 17. The A part, it is split in 2 points. We got 1 point out of 2. The answer key's equation is y equals x tan theta minus gx squared all over 2 v naught squared over cosine theta squared. Cosine squared. So we unfortunately messed up the subtraction. I do not know how, but gx squared over 2 v naught squared. We got the same exact answers on both sides. Cosine squared, and we just put plus tan theta x. I don't know where we got that from, but we missed it, and that caused the rest of our data for the entire FRQ to be off, as we tried numerous times but it didn't work out. For the next part, FRQ 17, part B, the answer should have been V naught equals 9.48 meters per second. We did not get any points because we got 11.8 meters per second with just calculating the average mean. So the way you would have gotten the answer is change of x equals 8.92 plus 8.96 plus 9.1 plus 9.07 plus 9.16 all over 5. That gives you a mean of 9.04 meters. And then you would use this equation, change of x equals v naught t, which would equal v naught cosine theta times t. T would equal change of x over v naught cosine theta. And then you would plug in into the second equation, change of y equals v naught sine theta times t minus 1/2 gt squared. And you would plug in this equation to wherever there's t. So you would get change in y equals v naught sine of theta times change of x over v naught cosine theta minus 1/2 g change of x over v naught cosine theta squared. Oh, that's gonna be a lot of numbers. And then we plug in this value into here and our theta of 40, which is given to us. So first of all, the v naughts cancel out here, which leaves sine of 40 times 9.04 cosine of 40 minus 9.8 over 2 times 9.04 over v naught cosine theta, which is 40 squared. Now, the beauty of this problem is since we have two unknowns, but we actually only have one unknown, because when the total distance in the x direction is traveled, y is 0. So that means this is all equal to 0. And then if you compute it and put v naught squared into one side, you get this equation. Tan of 40, and you solve for v naught squared and square root it, and you get 9.48 meters per second. Pretty neat, but we did not do that. We got 0 points out of 4. 2 was given for finding the average range, and 2 was given for substituting the appropriate equation into its main equation. Okay, now this is part C in question 17, the FRQ. This is asking to use the equation from part A to calculate the height of the projectile above the launch point when the projectile has traveled a horizontal distance of 5.3 meters. We got this wrong because the equation was just, the sign was switched. That's why we got everything wrong for this FRQ. The way you would do it, I'll do the point distribution later. Y equals v naught tan of theta minus gx squared all over 2v naught squared times cosine theta squared. And you would plug this all in. Y equals 9.48 from the previous problem, tan of 40 minus 9.8 times the distance, which is 5.13 squared, all over 2 times 9.48 times cosine of 40 squared. And then y equals the grand finale, 1.86 meters. There is 1 point for correctly substituting in values. There is 1 point earned for the correct answer, and there's 1 point earned for correct units. We would have, our equation, since it was plus, we would have added these two, of course, but this would have been a much higher value, and I don't think it would have made sense, but we ran out of time trying to figure out why our equation went wrong. Because since we would use this equation to fill out the tables and the chart to find the slope, we got all those wrong as well. Okay, this is the last question we got wrong. This is FRQ 17 question part B. This is asking us to fill in the table. So what we should have done was, in the table, the vertical axis should have been x, horizontal should have been t, time, independent variable, bang. 1 point was earned for indicating the variable will lead to a straight line graph, which is exactly this. It's a linear relationship. This was di. This next part is dii. Plot the data points for the quantities indicated in part 1 on the graph below. Clearly scale and label all axes, including units if appropriate. Draw a straight line that best represents the data. Okay, so okay, the graph, we did not do any of this part because our equation was wrong. We didn't get a legitimate answer. So time was 1.5 seconds here. This was 15 meters x. And then the lines were like 1, 2, 3, 4, 5. Oh my gosh, I'm an artist. 1, 2, 3, 4, 5. Right here, right here, right here, right here, and right here, and there. Bang. And then this is part DII. Okay. Short and simple. The slope is equal to the change of x over change of y, which is 12 meters over 12 meters minus 3 meters, which is, should be right here, over 1.2 minus 0.6 seconds, which gave us 9.57 meters per second. The linear regression gives 9.62, I believe. Yes, that's right. And now, if you plug it all into x equals v naught cosine theta times t, you would get v naught cosine equals 9.62. So the slope equals v naught cosine theta. You would divide by 9.62 and cosine of 40, which would give you 12.6 meters per second. And then similarly, if you just plug this with 9.57, you would get an equivalent 12.5. Oh my gosh, 12.5 meters per second. And that is it. We did not do this, nor this, and we lost a total of 6 points. We lost 2 here, 3 here, 1 here. 1 for DI, 3 for DII, 2 for DIII. Because we had the wrong equation just because of the sign in the middle. That is it for corrections.